Good afternoon, distinguished chairs, fellow researchers, and guests. I am Real Islam Rabbi, and on behalf of my co-authors, Dr. M. Popin and Dr. Zakir Hussain, I am excited to present our work titled Drowsiness Detection Using Real-Time Heart Rate Variability Data. So I will briefly cover the motivation behind this study, survey prior art, describe our methodology, discuss the results, and share future directions. So in the next slide, I will discuss the background study introduction. Every year, fatigue-related accidents claim thousands of lives worldwide. Additional detection systems rely mostly on visual cues like eye closures, staring behavior, which often react after the driver is already impaired. Our goal is to intervene earlier. So heart rate variability provides a window into the autonomic nervous system and can reveal fatigue before noticeable visual signs appear. By continuously analyzing heart rate variability from a wearable device, we aim to issue timely alerts that keep drivers and everyone around them safe. So in the next slide, I will discuss the literature review. Research interest in physiological signals has surged over the past decade. Meneses et al. Are demonstrated that machine learning on heart rate variability features can classify drowsiness states with promising accuracy. Lemonesi et al. Compared traditional classifiers with hybrid models that fuse multiple signals, showing clear gains in robustness. So, Artunas et al. Built an intelligent real-time system integrating heart rate variability sensors directly into the vehicle cockpit. Meanwhile, Vicente et al. Provided seminal medical engineering evidence linking heart rate variability patterns to fatigue. So in the next slide also, recent wearable innovations such as those explored by Betty et al. And multimodal fusion approaches by Cho et al. Underline a clear trend. Combining biosignals with advanced analytics delivers earlier and more reliable detection. So collectively, this works inspires our focus on a purely heart rate based real-time solution. So in the next slide I discuss methodology. Methodology, you can see in this figure, this is the workflow of the drowsiness detection system. So we collect bit the very interval data with the empathic embrace plus a clinically validated wrist-on sensor. After preposing to filter artifacts, we compute a standard heart rate variability features in both time and frequency domains, then feed them into a three-layer artificial neural network. The network classifies each 30-second window into alert, early doji, and severely doji states. So this pipeline workflow, acquisition preprocessing, then speech extraction, artificial neural network detection, and yeah, driver alert, and then the end-to-end latency is under 250 milliseconds, enabling near real-time feedback. So in the next slide, I will discuss the results and analysis. So you can see pulse and respiration trends. Here you see pulse rate and respiratory interval traces over time for a representative participant. Note that the gradual decline in heart rate variability as fatigue sets in, mirrored by elongated respiration cycles. So in the next slide, you can see the power spectral density of heart rate variability lower frequency and higher frequency band. So frequency domain analysis further reveals a pronounced shift from high frequency parasympathetic to low frequency sympathetic power and established biomarker of drowsiness. So in the next slide, you can see training validation accuracy, training and validation loss trends. Our neural network converges stably with minimal overfitting. Validation accuracy plateaus around epoch 18, while validation loss continues to drop, signaling sound generalization. So in the next slide, you can see performance matrices. Ultimately, the model attains 91.36% accuracy and 85.33% precision, 82.33% recall, and an F1 score of 83.33% on unseen drivers. You can see that the confusion matrix confirms balanced performance across all three Drowsiness states. In the last slide, you can see conclusion and future works. In summary, real-time heart rate variability monitoring offers an intrusive early warning mechanism against driver fatigue. Moving forward, we plan to minimize the feature set of embedded use, integrate cloudless on-device inference, and explore transformer and based architectures for sequential modeling. So this slide, acknowledgement, Malaysian government, FRGS grant and TMND fund. We are grateful for their commitment to road safety research. So in the next slide, these are slides. We gratefully acknowledge the foundation studies cited here. Please see the paper for the full list. So yeah, thank you for your attention and I welcome your questions. Yeah.